In this concept, we're going to talk about rational exponents. Now, for any real number b and for any positive integer n, so if we have a number b inside a radical of index n, right, we can convert this expression, so the nth root of b can be converted to b to the power 1 over n, and vice versa. So if we started from b to the power 1 over n, we can rewrite this as the nth root of b. Okay? Now, if b is less than 0, so if it's negative, and n is even, then a complex root may exist. You would get an imaginary number. Let's look at some examples. Simplify. 4 to the power of 1/2. So again, this is the index of the radical is the same as the denominator of the exponent, which in this case is 2. So this is the same as the square root of 4, which is 2. Also, if we start from square root of 4, we can convert that to 4 to the power 1/2, which gives us 2. Now, 4 to the power 1/2, let's invoke the law of exponents. So in this case, we can rewrite 4 as, so this is 4 to the power 1/2, right, which is the same as 2 squared to the power 1/2. And then according to the law of exponents, we can basically multiply this 2 in this power by the 1/2 in this power, right? So something to the power raised to something to the power of something raised to the power of something is basically that something to the power of the product of those two powers. So in this case, we have 2 to the power 2 raised to the power 1/2. We can multiply 2 and 1/2. Right? We can multiply the 2 and the 1/2 together. So we'll get 2 to the power of 2 times 1/2, which is 1. So 2 to the power 1 is just 2. So this actually checks, right? Let's look at another example. 81 to the power minus 3/4. In this case, we use the negative exponent rule. So the negative power is the same as that expression with a positive power in the denominator. So 1 over 81 to the plus 3/4, right? And then the 4 in this denominator of this power is essentially the index of the root around 81. So it's 81, the 4th root of 81, and then this 3 is just cube. Right? And we can simplify this. So the 4th root of 81 is 3, right? So 3 times 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. Okay? So the final result is 1 over 27. So in general, for any non-zero real number b and any integers m and n with n greater than 1, again, the index of the radical is this of some expression is the same as putting that index in the denominator of the exponent of that expression. So the nth root of b to the m is the same as b to the m divided by n in the exponent. Okay? Which is also the same, actually, as flipping these, right? So you see here the m exponent is inside the radical with index n. Well, we could say the radical with index n of b raised to the mth power. Okay? So either of these is fine. And again, if b is negative, less than 0, and n is even, a complex root may exist. Let's look at more examples. Simplify. The cubic root of 64 squared. So again, we take the index of the root, or the radical, and then we put it as a denominator. Oops. Yeah, put it as a denominator here. So then you have 64 to the 2/3 power. So 64 is really 4 cubed, right? So 4, again, times 4 times 4, 16, and then 16 times 4 is 64. So 4 cubed to the 2/3 power, and then look at what happens. We can multiply this and this. So 3 cancels with the 3, right? Because this is, so it's 3 times 2/3, right? So this is the same as 3 over 1 times 2/3. Divided by 3 is 1, divided by 3 is 1. So you just end up with 4 squared, which is 16. Okay? So we went from here to here. Okay? Following all the steps we talked about. Write the following radical expressions, or this one, in exponential form. So the fifth root of m to the fourth is the same as m to the power 4 over 5. Okay? Again, the index of the radical goes in the denominator of the power. Write the following exponential expression in radical form. X to the 5/3 is the same as the cubic root of x to the 5th. Okay, and here we have some exercises. Please pause the video, work on these, and come back for the solutions. Okay, write the following radical expression in exponential form. So we have the 7th root of a cubed times b to the 5th. So this is the same as a cubed times b to the 5th to the 1/7 power, right? Which we can distribute the 1/7 to each of the two terms in the expression. So we'll have a to the 3/7, right? 3 times 1/7 is 3/7, times b to the 5/7. Okay? We could have also said a b squared to the 3/7 power. Okay? Because again, a cubed b to the 5th is the same as ab squared all to the 3rd. So ab squared all to the 3rd times 1/7, right, when we convert the radical, becomes ab squared to the 3/7, which is what we have here. Okay, this is another way to express the solution. Next examples. Exercises. Simplify the following expressions. The cubic root of 125 a to the 6th b squared gives us, so we can distribute the cubic root to each of these terms in the expression. So the cubic root of 125 is 5 times a to the 6 times 1/3 from the cubic root, so 6 over 3, times b squared times 1/3, which is 2/3. Right? So, which is equal to 6 over 3 is 2, right? A squared, and then b to the 2/3. Right? Or, again, another way to write it would have been AB to the 1/3, right, squared. Okay? Because again, when you distribute this 2, so you'll have a squared, and then you'll have b to the 1/3. Oh, this is too big. B to the 1/3. Right? If you wanted to distribute this, you can go back to this. Go back from here to here. Okay? Either one of them is fine. The square root of 16x to the 8th times b to the 12th is equal to, again, distribute the square root to 16, x to the 8th, and b to the 12th. So square root of 16 is 4, x to the 8 over 2, right, because it's x to the 8th to the 1/2, because we have a square root, right, and then b to the 12 over 2, right, which is equal to 4, 8 over 2 is 4, 12 over 2 is 6. Okay? X to the power 1/2 plus 1 divided by x to the power 1/2 minus 1. So here we can actually multiply by the complex conjugate, right? So x to the power 1/2, again, this is essentially square root, right? So this is the same as just square root. So we can just multiply by the square root of x plus 1 and the square root of x plus 1. And this will give us, so this becomes a difference of two squares, so square root of x squared is just x, and then minus 1, right? That's my denominator. And then here we'll have square root of x times square root of x is x, plus 1 times plus 1 is plus 1, and then plus 1 times square root of x is square root of x, plus square root of x, which is plus 2 square root of x. Okay? And this we can stop at. This will be our final result. Next exercise, write the following exponential expression in radical form. M times n to the 3/7 power is equal to m cubed. Oop, what happened to my pen? Yep, I think my pen locked, but it's essentially m cubed times n cubed, the 7th root of. Okay? So the 7th root of m cubed n cubed. Okay? This is it for this concept. See you in the next video.